Alright, you guys, this is Unit 3 review. We're going to do odds for this review. The most important thing on this entire review is for you to remember your angle relationships. If lines are parallel, then corresponding alternate interior and alternate exterior angles are congruent. Consecutive interior, that means same side inside. Those angles are supplementary. Okay? So when we look at this first page, I've highlighted all the parallel lines. And we want to take the angle relationships, apply them to find all the other angles. So the first thing I want you to see is with number 1, 70 is vertical to the x. And we always know vertical angles are congruent. Then 70 and y are same side inside of those parallel lines. Same side inside of those parallel lines. They're on the same side of the transversal. So they are supplementary. So we're going to take 180 minus 70, and that gives me 110 degrees for y. From there, I know that y and w are vertical angles, and vertical angles are always congruent. So I've solved for x, which is 70 degrees, y, which is 110, and w, which is 110. Don't worry about the blanks until after you've marked your picture. Then go back and fill in the blanks. The next picture, number 3, I've got the highlighted parallel lines. I've got 65 over here, and I'm trying to find all these angles over here. What you want to do is the first thing you want to do is solve for an angle that you know. For instance, 65 plus whatever that angle is has to be a straight line. So this angle plus 65 is a straight line. So 65 plus whatever that guy is, we'll call him A, angle A, equals 180, because all straight lines add to equal 180. We subtract 65 on both sides. A is going to equal 115. So this angle right here is 115 degrees. From there, I know the 115 and the x have a relationship together. They are corresponding. 115. I know corresponding are congruent when lines are parallel. When I look at that 65 and I look at that y, they also have a relationship. They're on alternate sides of the transversal and on the outside. If I cover up the inside of those parallel lines, 65 and y are on the outside. So those are alternate exterior. And I know alternate exterior are congruent. The last step is to find z, and he is going to be corresponding to x. They're in the same spot. So z is 115. Then I go back and fill in my blanks. I've got x is 115, y is 65, and z is 115. Number 5, highlighted those parallel lines. I'm going to concentrate on one transversal at a time. So I'm going to cover this side up, and I notice that 80 and z are same side inside. So we know those guys are supplementary. So 80 plus z has to be 180. So you would subtract 80 on both sides. You get z equals 100. Then I cover up that transversal and I focus on this other one. 75 and the y have something in common. They have a relationship. they're going to be on opposite sides of the transversal and on the inside of those two lines. So those are alternate interior. And I know when lines are parallel, alternate interior are congruent. So y is 75. 75 and the x, they make a straight line together. Or I could use consecutive interior angles are supplementary. So they're also supplementary. So we could do 75 plus x equals 180. And then we subtract 75 on both sides to get x equals 105. So x is 105 degrees, y is 75 degrees, and z is 100 degrees. Let's look at page 2. Page 2 has this awesome problem on it that we saw in our homework. So what I would recommend you doing is first highlighting these in different colors. So AD parallel to BE. So those are going to be my pink lines. AC parallel to DF. Those are going to be my yellow lines. And then let's do blue. BD parallel to CE. Okay. Hopefully now that we've got the lines highlighted, we'll be able to see the relationships a little bit better. We're just going to go through and we're going to tell whether or not we can prove a certain color of line parallel based on the given information. So angle 10 is congruent to angle 2. Angle 10 is congruent to angle 2. So you just want to focus on that side of the picture. Notice they're on opposite sides of the blue line on the inside of those pink lines. So do you see how it goes blue to pink? And this one goes blue to pink. So I am going to be able to tell a relationship here because they're stuck between the same two lines. Now what is a relationship? What would you call that? They're on opposite sides of the transversal on the inside of your lines. So we call that alternate interior. When alternate interior are congruent, then the lines are parallel. Notice what two lines they're touching. They're touching the two pink lines. So pink is what we can tell parallel. A. Okay? Let's try it again with number 9. 10 and 5, congruent. So I'm going to cover up the picture that I'm not talking about just to focus. 10 and 5 go blue to pink and blue to pink. But notice what two lines they're both touching. They're both touching blue. So when we think about their relationship as being alternate interior, we want to notice that the two lines that are going to be parallel are going to be the blue ones. Notice there's only one pink line we're talking about, and that guy, he's our transversal this time. So blue lines are going to be parallel because of alternate interior. 8 and 3. 8 is over here and 3 is over there. This one's a little bit more tricky. Notice 8 goes yellow to blue. The 3 goes yellow to blue. So do you think they're going to be congruent? Yes, they are. And notice what two lines, don't look at that, what two lines are they both touching? Okay, they're both touching the one blue line, but they're also both touching the two yellow lines. So it's going to be the yellow lines that are going to be parallel because of corresponding. These guys are bottom left, bottom left. So yes, they're going to be parallel, it's going to be the yellow set that we see, and the reason would be corresponding. Let's look at this one. Angle DBC. So all of this guy, DBC, he's right there, 9 and 10 put together, plus 7 equals 180. Okay, so I want to isolate what I'm talking about. Notice I've got the one transversal, which is yellow, and I've got 2 angles on the inside of those blue lines, and they're supplementary. So their relationship is consecutive interior, and they are supplementary, so those lines are going to be parallel. Notice the angles that we're talking about, they're touching the blue. Do you see that? So our blue lines are going to be parallel. So that's C. The last one is 15. It says 4 is congruent to 9. 9 is right here. I kind of covered him up. I'll just circle 4 real big and circle 9 real big so we can see that. 4 and 9. So ignore the blue line that we were just talking about. I'm going to white him out. Ignore this guy because you don't care about him. You're just looking at this pink transversal and then the yellow lines. So if you notice, 9 and 4 are on opposite sides of the pink transversal. Opposite sides of the pink transversal on the inside of those yellow lines. So the yellow set is what's going to be parallel. So that was B. Alright, oops, sorry, I kicked the machine. Alright, hopefully that helps a little bit. You will be able to use a highlighter on your test. Just ask your teacher, but hopefully that'll help. Let's look at number 17. It says graph the following equation. We know that when we are graphing, you want your equation to look like y equals mx plus b, where m is the slope and b is the y-intercept. So in order to graph 17, I first have to move everything over to one side and solve for y. So we subtract 3x minus 3x, and you get 2y equals negative 3x plus 8. Then you want y by himself, so you divide everything by 2. So you get y equals negative 3 over 2x plus 4. So this is the equation I'm going to graph. This is the slope that tells me direction, and this is the y-intercept. We know when we're graphing that we start with the y-intercept of positive 4. We start there. Then the slope tells us the direction we should go. So this one tells me to go down 3, right 2. It's always rise over run, but because it's negative, I don't rise, I fall. So I go 1, 2, 3 over 2. 1, 2, 3 over 2. Down 3 over 2. And that is my line. Number 19 says use point slope equation to write the standard form for each. Okay, so standard form is where you go ax plus by equals c. So for instance, it's kind of the form that was in our equation earlier. It's where all your x's come first, then your whole numbers, or excuse me, then your y's, then your whole numbers. And the leading coefficient, that leading 3, was positive. And that's what you want for standard form. So the first thing we want to do is be able to write the equation of our line. We know writing the equation of our line is a two-step process. The first step is to find the slope. The second step is to plug in a point slope. So in order to find my slope, I label my points x1, y1, x2, y2. And the slope equation is y2 minus y1 over x2 minus x1. So 10 minus 5 over negative 3 minus 2. We get 5 over negative 5, which is the same thing as negative 1. So that's my m. Now that I've got my slope and I've got a point, I'm going to plug it into point slope. So y minus y1, which was 5, equals m, which is a negative 1, times x minus x1, which was 2. Distribute. Y minus 5 equals negative 1x plus 2. And then add that 5, add the 5, and you get y equals negative 1x plus 7. This is in slope-intercept form. So if it asked me for slope-intercept form, I would stop here. But it asked me for standard form. So if you want to take slope-intercept form, that's an x, and turn it into standard, then what you want to do is move these x's this way. So we're going to add 1x to cancel. We're going to add 1x over here. So my standard form equation is 1x plus y equals 7. X's came first. It's a whole number. It's positive. Then the y's. Then the whole numbers. That's it for pages 1 and 2. Please feel free to come in and get tutoring if you need it. We are here for you guys.